Good morning, everyone. I am Dr.A.Sethupathy, Assistant Professor, Department of Mechanical Engineering, SNS College of Engineering, Coimbatore. In this topic, the science of fluid dynamics. So, the fluid dynamics is the study of how gases and liquids move, and Bernoulli's theorem plays a crucial role in understanding these movements. In this presentation, we will dive deep into the applications and the limitations of Bernoulli's theorem. So in fluid mechanics, we are using the theorem of Bernoulli's equations and Bernoulli's theorems. So this theorem deals with the fluids applications in the industry based or equipment where the fluid used followed by these Bernoulli's equations. So in this topic, we will study detail about the Bernoulli's equations or Bernoulli's theorems used in the fluids. So the principle of Bernoulli's theorem. So the basic idea, Bernoulli's theorem states that as the speed of your fluid increases, so the speed means velocity, the pressure within the fluid decreases. So if you increase the velocity, pressure will be automatically decreases. This relationship has important implications for a wide range of applications. So equation and variables. The theorem is expressed mathematically as P1 equal to pressure and half rho V1 square equal to rho equal to density of the fluid, V1 equal to velocity of the fluid, then plus rho G. G means the gravitational force and H1 means the height. So the fluid throwing a pipe in any area, the pressure and velocity is same. This is the Bernoulli's equation tells. So this is the formula here. P is the pressure and rho is the density, V is the velocity, H is the height of the liquid from the pipeline. And the subscripts denote points in the fluid flow. So real world examples, the theorem helps explain phenomena such as the lift generated by airplane wings, the operations of fitted tubes, and the design of hydroelectric power plants. So design and operations of aircraft wings. Curved shape airplane wings are curved, which means that the air flowing over the top of the wing must travel further and faster than the air flowing underneath. This creates a region of low pressure above the wing, which helps lift the airplane off the ground. So maneuverability by adjusting the shape and orientation of the wing, pilots can alter the lift and drag forces acting on their aircraft. This allows for smooth takes off, landing, and turns in flight. So engine thrust may aircraft rely on jet engines for propulsion, which means they generate significant thrust. So Bernoulli's theorem helps explain the interaction between the air flowing over the wing and the exhaust gases flowing out of the engine. So wind turbines and hydroelectric power plants where the Bernoulli's theorem used and how the Bernoulli's theorem applied in these areas. So wind turbines, as the wind flows past the blades of the turbine, creates areas of low pressure on one side and high pressure on the other. This pressure difference causes the blades to spin, which turns a generator and produce electricity. Hydroelectric power plants, water flowing through a hydroelectric plant's turbines generates energy in the same way that wind does. Bernoulli's theorem helps engineers design these structures for maximum energy efficiency. The third one, new applications. Researchers are exploring way to harness the power of ocean currents and other fluid movements using the principle of fluid dynamics and Bernoulli's theorem. So pitted tubes and differential pressure sensors, how do they work? When a fluid in a motion, it has more kinetic energy than when it is at rest. So Bernoulli's theorem states that this kinetic energy is proportional to the fluid pressure. By comparing pressure at 2 points, engineers can calculate the fluid speed. So to find the velocity. So what are they? Fitted tubes and differential pressure sensors are common tools used to measure the speed and pressure of fluid in motion. These devices work by comparing the pressure at two different points in the flow. So what are the applications? Fitted tubes and pressure sensors are used in a wide range of industries, including aviation, automotive engineering, and biomedical research. So what are the challenges and limitations in Bernoulli's theorem? So non-ideal fluids. Bernoulli's theorem applies only to ideal fluids, which are defined as having no viscosity, compressibility, or other complicating factors in real world conditions. Fluids often have